Okay, so ladies and gentlemen, in this lesson, this is going to be part 2 for finding the average rate of change. Rate of change over an interval from a table, from a graph, and from an equation. This is part 2. So in the previous lesson, we looked at finding the average rate of change for a line. And we concluded that the average rate of change for a line is just the slope of that line, which we said was the rise over the run and so forth. Okay? The change in y over the change in x, y2 minus y1 over x2 minus x1, the rise over the run. Okay? We also began discussing how to find the average rate of change for nonlinear functions. That was the previous lesson. So now in this lesson, I want to actually just practice this a little bit. Let's look here at this first problem. It says, find the average rate of change over the given intervals. And here, it gives us the intervals for this function g of x right here. So, here's how you do it. The average rate of change is defined to be the change in y over the change in x. The rise over the run. So, my question to you is, what is g of 4 minus g of 0 divided by 4 minus 0? So this is the y value when g is, when x is 4. So, when x is 4, what is the y value? It's 2. And what is the y value when x is 0? What's the y value right here? 0. Yeah, 0. Now, 4 minus 0, so that's y2 minus y1 over x2 minus x1. Does this make sense? This is the rise over the run. The change in the y's divided by the change in the x's. So that is 2 over 4, which is 1/2. So what is the average rate of change between 0 and 4? What is it? What is it? What is it? I'm sorry, I didn't hear you. 1/2. Okay. Now, by the way, if I took this line right here, which is known as the secant line, what is the slope of that line? What's the rise over the run? So what's the rise? It's up 2. The rise is 2. The run is 4. Understood? Okay. So let's do this. What's the average rate of change between 1 and 4? Well, that's g of 4 minus g of 1 divided by 4 minus 1. So what is g of 4? What is g of 4? What's the height when x is 4? 2. Minus, what's the height when x is 1? Sure about that? What's the height when x is 1? Oh, my bad. I just made a mistake. Supposed to be going up to the curve, not that crazy line that I just drew. Okay, so let me get back to it now. What is the y value when x is 1? 1, of course. So, 4 minus 1 here. So what is 2 minus 1? 1. What is 4 minus 1? 3. So, here you see that the slope is 1/2, and here you see the slope is 1/3 of the secant line that goes between those 2 points. So once again, this is not a line, this is a square root function. Alright? So in nonlinear graphs, the average rate of change is different depending on the interval that you're using. Okay, so this line right here, the rise is 1 and the run is 1, 2, 3. All right, so let's look at this next problem over here. You have g of t, where the input, gosh, that is a confusing looking problem. Let's not worry about what the actual function is. Let's just look at the graph that's given here, and we're going to go from 0 to 3. So the change in y over the change in x is g of 3 minus g of 0. So what's that value? So this is going to be over 3 minus 0. So what is g of 3 in this case? What do you say? I think these are whole numbers, so it's actually 23. And 0. What's the x value when, what's the y value when x is 0? 22. Minus 22. All over 3 minus 0. So, 23 minus 22 is 1 over 3. So right here, the slope is 1/3. The rate of change, the average rate of change is 1/3. Let's look at the interval between 3 and 8. G of what? G of 8 minus G of 3. All over 8 minus 3. What is the y value when x is 8? It is 28. 28 minus, what is the y value when x is 3? 23. All over 8 minus 3. So we simplify this. On the top we get 5, and on the bottom we get, and so that is 1, right? So the average rate of change is 1. Now this is, I'm going to skip this last problem here. I'll let you do that on your own. Do you understand how to find the average rate of change from a graph? Okay. Now this formula that we're using works the same way, whether you're using a graph, whether you're using a table, or an equation. So we're going to see that in the next couple examples. Here you see a table given, and they want us to find the average rate of change from this table. So the average rate of change would be f of something minus f of something else all over the x values. All right, so our interval here is 1 to 3. So this will be f of what? 3 minus f of 1 all over 3 minus 1. So what is f of 3 equal to according to the table? Now x is 3, so what is the y value? 16 minus, and what is f of 1? 4. So this is going to be minus, this is over 3 minus 1. So 16 minus 4 is 12, and 3 minus 1 is 2, and 12 divided by 2 is 6. Okay? What about from 0 to 2? So we just did 1 to 3. What about 0 to 2? Let me let you do that on your own. Practice it, and I'll give you the answer. So you can pause the video right here, give it a shot, and then we'll see if you get it right. Okay, so did you do it? Did you come up with an answer? So we should have had 8 over 2, which is 4. Okay, so do you guys understand how the slope of the secant line, or the average rate of change, it's different depending on the interval that you use for any given nonlinear function? And here is an example with a table. All right. Any questions here? Okay, so there's a few more examples. Let's take a moment and try, just for fun, let's do both of these examples right here in the middle one. So right now, if you're watching the video, I would encourage you to pause it to practice this, and then we will check this middle problem. Okay, so we're looking for the change in y with the change in x here. So this is going to be 8 minus 4 on the bottom. And what is the y value for 8? It's 49. What's the y value for 4? It is 25. So 49 minus 25 is what? 24? All over 4. So you simplify that and you get 6. What is the rate of change between 5 and 7? So it's going to be the y value for 7, which is 43, minus the y value for 5, which is 31. So let's see, I get, what, 12? All over 7 minus 5, which is 2. So that comes out to be 6. And oh my goodness, it happens to be the same. What does this mean? I'm not looking at this graph. I don't know, but what if I see 2 of these that have the exact same rate of change? What could this potentially be a graph of? This could be a line. Could be. I don't know. We have to graph it, but it also might be just a total coincidence that the slope in both of these cases happens to be 6. It might be a coincidence, but it also might be a straight line. I really don't care. You know, maybe it is, maybe it's not. That doesn't concern us right now. We're just interested in how do you find the rate of change. But this is important that you realize that in a line you can get well, in a line, you will get the same slope, no matter what the interval is. Big, small, it doesn't matter. Okay? So what about if I give you an equation? Well, we're using the exact same formula, the change in y over the change in x. Okay? So I like this formula, f of b minus f of a all over b minus a. Well, I've been using that formula all along for both the graphs and the equations. So let's use it here. The change in y over the change in x is equal to f of 5 minus f of 0 all over 5 minus 0. So f of 5, this is where you plug in 5 into this equation, and I don't care how you do it. Maybe you do it by hand because you're brilliant. Maybe you do it, you know, in your head because you're brilliant. Maybe you have to use your calculator. Either way, this is 3 times 5 minus 2. All of that minus 3 times 0 minus 2. All over what? 5 minus 0. Do you guys see where I'm inputting those x values into the equation? Once again, I don't care whether you use your calculator or whether you show me this on your paper. You know, every teacher is going to require different things, but bottom line is that you understand the input is 5, and 0, and so I need the outputs. What's the output for the input 5? What does this give you right here? 15 minus 2? 13. Minus, what is this output? 0. 3 times 0 is 0. Minus 2 is negative 2. So that's 13 minus a negative 2. Don't lose that. That's minus a negative 2. All over 5 minus 0. What does minusing a negative 2 mean? Add 2. So 13 plus 2 is 15. All over 5. And what's 15 divided by 5? 3. Understood? So all this is y2 minus y1 over x2 minus x1. It's the rise over the run, basically, except we're not talking about just lines anymore. We're talking about any function. Okay, so I've got a couple more examples here. Let's take a moment and do, I want to do both of these problems right here, this one and this one. So if you're watching the video, I want to encourage you, pause the video, see if you can do it ahead of me, and then let's check and see if you got the right answer. So I'm going to pause my recording right now. Okay guys, so I just want to go ahead and work this problem out now. Let's finish it up. So the change in y over the change in x is equal to, I'm going to write this out the ugly, long, drawn out way a couple times. Please understand that this place right here, I'm not requiring you necessarily to do, at least for my purposes, but maybe some other teacher would like to see this sort of thing. My main concern is that you understand what to do with this information. So you have these inputs. You're going to plug them into this function right here. and do the y2 minus y1 over x2 minus x1 deal. So here it is. This is going to be 2 squared plus 3 times 2 minus 1. All of that minus 0 squared plus 3 times 0 minus 1. And I actually want to recommend that you put parentheses around your inputs no matter what. The place where this especially makes a difference is if you're inputting a negative number. If you square the negative number and you don't put the parentheses around that negative number, it will cause you to get a wrong answer. I'm not going to go into the reason why right now, but just know you need to put parentheses around those inputs, especially when the inputs are negative. Okay, so this is going to be 2 minus 0. All right, so simplifying this, I'm going to do this in my head. So this is 4 plus 6 minus 1. It's 10 minus 1, which is 9, minus 0 squared is 0, plus 3 times 0 is 0, minus 1. So that's a negative 1. So it's 9 minus a negative 1, all over 2 minus 0. 2 minus 0. So this is 9 plus 1, which is 10, all over 2, which comes out to be 5. For the next problem, same story. Change in y over the change in x. This is equal to the square root of 16 plus 1 minus the square root of 4 plus 1 all over 16 minus 4. So this comes out to be 4 plus 1, which is 5, minus 2 plus 1, which is 3, all over 16 minus 4, which is 12. So 5 minus 3 is 2, all over 12. That comes out to be 1/6. Okay, raise your hand if you got that right. Wonderful. Okay, so ladies and gentlemen, this is finding the average rate of change using a graph, a table, and an equation. This is finding the average rate of change over an interval, especially focusing on non-linear functions. Okay, but when it is linear, what is the average rate of change? What is it? It's just the slope. Okay. All right. So thank you for watching, and we'll see you in the next video.